ইন্ট্রোডাকশন কি স্যার প্রথমে
হ্যাঁ
আপনারটা দিব আর
হ্যাঁ, আমি প্রথমে, তারপরে
হ্যাঁ
ডক্টর
ডক্টর
সাইদ
আলী
আসবেন।
যখন শুরু করে তাহলে তখন ওনার ইন্ট্রোডাকশনটা স্যার দিয়ে দেবো স্যার।
হ্যাঁ, অসুবিধা নাই, থ্যাংক ইউ।
স্যার ওই আস্তে আস্তে হয়তো স্যার জয়েন করতে থাকবে, 40 জনের মতো অলরেডি জয়েন করছে স্যার। আমি একটু ইন্ট্রোডাকশন দিই যেহেতু স্যার আপনারও একটু তাড়া
হ্যাঁ
আছে। আপনি হয়তো স্যার শুরু করে দিলেন।
হ্যাঁ, ইনশাআল্লাহ।
আসসালামু আলাইকুম প্রেসিডেন্ট। যেটা আমি তোমাদের ক্লাসে বলেছি যে আমাদের এই কোর্সে আমরা তিনটা ক্লাস, আমাদের যারা আহ, বাংলাদেশি আহ, কিন্তু বাইরের ইউনিভার্সিটিতে প্রফেসর ওনারা আছেন, ওনারা তিনটা লেকচার দেওয়ার জন্য আমাদেরকে সুযোগ করে দিয়েছেন। এই জন্য আমি মুশাররফ জামান স্যার এবং ডক্টর সৈয়দ আশিক আলী ওনাকে আন্তরিক ধন্যবাদ এবং অভিনন্দন জানাচ্ছি। ডক্টর মুশাররফ জামান স্যার প্রথমে লেকচার দিবেন, তারপরে ডক্টর সৈয়দ আশিক আলী লেকচার দিবেন। আমি প্রথমে স্যারের কিছু সংক্ষিপ্ত জীবনী তোমাদের সামনে তুলে ধরছি। Dr. Musharraf Zaman joined the University of Oklahoma Civil Engineering and Environmental Science faculty in 1982 after completing his PhD from the University of Arizona. He was promoted to full professor in 1993 and was named the Aaron Alexander Professor in 2003. He served as the Associate Dean of Research and Graduate Education of Oklahoma University College of Engineering from July 2005 to December 2013. He has been alumni chair, professor of petroleum and geological engineering since 2010. He is a prolific teacher and a highly accomplished researcher. During his tenure at Oklahoma University, he was received several prestigious and national level teaching awards from the American Society of Engineering Education. He also received the lifelong title of David Rose Board Professorship, the highest teaching award given by Oklahoma University. During his tenure at Oklahoma University, he has received more than 60 million US dollar in external research funding from various state and federal agencies and industries, including major funding from the US Department of Transportation, NSF, and Oklahoma Department of Transportation. He has published more than 475 peer-reviewed journal and conference papers. Imagine, can you imagine? And 17 books and books chapters. Several of his papers have won prestigious award from national level societies and organizations. He is a fellow and life member of the American Society of Civil Engineers. He serves as editor-in-chief of International Journal of Pavement Research and Technology and co-editor of International Journal of Geomechanics, ASC, since October 2013. He has been serving as the director of the Southern Plains Transportation Center, which is a regional university transportation center. তাহলে তোমরা বুঝতে পারছো যে কার লেকচার আজকে তোমরা শুনছো, এবং আমিও লাকি যে আমিও স্যারের লেকচার শুনবো। আমি স্যারকে রিকোয়েস্ট করছি যে স্যার তার লেকচার শুরু করার জন্য।
Thank you very much, Mizan, and assalamu alaikum to all. I think this is indeed a privilege for me to be able to talk to you all. I think, as I normally tell to my students here at the University of Oklahoma, that people like us, we are sort of past, and you
স্যার
all
আপনি
will be the.
স্যার একটু আপনি যদি স্যার অনুমতি দেন স্যার, আমি কি একটু রেকর্ড করবো স্যার?
হ্যাঁ, অবশ্যই
স্যার
অবশ্যই
থ্যাংক ইউ স্যার।
অবশ্যই, thank you. So as I say normally, to my students here, that we are kind of past, and the people who are attending, this lecture, you are the future, and I really mean it. So what we could not do ourselves, we would like to see that you do those things. There's plenty of opportunity. So we're going to give we're going to talk about two different problems, two topics. So I will talk for about maybe a half an hour or so, or 35 minutes. I will try to, but normally it is difficult to actually maintain time. Uh, but this is very exciting technology. So my uh, presentation is kind of a technology driven, and Dr. Syed Ashik would be talking more of a practical, type of thing. So having worked in this area for a long time, what I have found out that if you want to solve one problem, and then there will be 5 new problems actually coming up through that process. So if we collectively work, still these problems are too big. I'm talking about even in the US. So this is a very interesting topic, and I'll try to actually do my best. And I would like to actually see this more as a dialogue. So if you have any questions, so please ask me so that I can share whatever I know. So with that, I'm going to actually share my screen so that I can, pull my presentation. Uh, so I presume you are able to see are you able to see my screen?
Yes, sir,
Yes,
we
sir.
can see it.
Yes, sir.
Okay, so let me I have to go to the presentation mode so that way. Uh, okay, so this particular technology that we have uh, is is called intelligent asphalt compaction. Intelligent asphalt compaction. And the one that we have, and we have a patent on this particular technology, is called Intelligent Asphalt Compaction Analyzer. It is abbreviated as IACA. And what does it do, this particular technology? It essentially it's a tool for quality control of asphalt pavement during construction. That's important, during construction. So I want to acknowledge my students. So Dr. Syed Ashik Ali would be talking here. Mohammed Ashikur Rahman, he is finishing his PhD from California. And then Sagar Ghosh also just recently finished his PhD. Uh, so what is the thing that we are trying to do here? I think somehow let me see. Okay, so construction quality is extremely important. If you do not have a quality construction, then it does not matter, whether you have good material, whether you have good engineer, good design, nothing would really matter. So construction quality is extremely important. Traditionally, this construction quality is maintained through spot checking. You can see here that this soil compaction, subgrade compaction, for example, the width of this drum is about 8 feet, right? And how you are maintaining quality. I think there are a couple of things that you're seeing here. The nuclear density gauge. That's how you measure spot check. Dynamic cone penetration. You have a lightweight deflectometer, or sometimes you actually do coring, which is a destructive process. All of these tools that we use currently, they are spot check. Now, that does not mean a spot checking does not solve the problem. We all know that because of the extent of the pavement is very different, is very large. There's a big scale difference, very big scale difference. So we need to think about something new, different. And that's why this intelligent compaction comes in. So what we want to know is the overall compaction quality of the pavement that is being constructed overall. So we should be able to, you know, look at the quality of the entire pavement rather than spot checking. So this particular technology does that. So overall, I think I'm going to actually give you a very brief description of what it is. So this technology is based on the vibration. As you know, that this compactor, you have seen, I'm sure that all of you are, most of you have seen the construction, pavement construction. So it is a vibratory compactor. The compactor has kind of an eccentric weight. It vibrates, so that vibration. So what we are doing is we are recording the vibration in real time. So, so we have an accelerometer that measures the vibration, and then we have tools to, and then of course we have GPS, and then also we have a temperature sensor, because you need to have temperature is also extremely important in this process. So GPS antenna looks at the location, then vibration of the compactor is recorded in real time, and also the temperature, and then it is processed also in real time, and then it displays the level of compaction. Now, one thing is very, very important to note here, that so you're compacting asphalt layer that you're constructing, but it is placed on other layers, right? As you know that asphalt pavement is a layered system, So you have subgrade at the very top, then you have some base and sub base, and on the top you're doing your construction. So actually this vibration, as you know, it's a coupled system, this vibration. So how the compactor is going to respond depend on what you have below. So it's a coupled system, that is something. So in other words, as you're compacting and the asphalt layer is getting more densified, the vibration, nature of vibration is changing. So there is a video here that will tell you. I hope that you can listen. You have the sound also.
We expect performance and long life out of so many things we buy, from our computers and appliances to the vehicles we drive. Why not the same for the roads we drive on? Generally, pavement performance is not something motorists think about, but it is something pavement engineers think about a lot. And engineers know that achieving good compaction during construction is the most economical method of increasing the lifespan and performance of asphalt pavements. Compaction increases pavement density, which makes our roads stronger and less prone to cracking and rutting. Longer-lasting roads mean fewer work zones, delays, and lane closures. Better performance means a more comfortable ride. Traditionally, asphalt pavement is tested for density after rolling operations are completed. Conventional quality control techniques are often time-consuming, costly, and can be destructive. Pavement cores are extracted and analyzed after completion of the operations. This method checks the pavement at individual points and does not reflect the overall quality of the entire asphalt pavement. The Intelligent Asphalt Compaction Analyzer, or IACA, is a roller-mounted device that provides real-time data on compaction inconsistencies during the construction of asphalt pavements. The Highways for Life Technology Partnerships Program provided a grant to Haskell Lemon Construction in partnership with the University of Oklahoma to refine and test the IACA technology. The prototype, consisting of a global positioning system receiver, the compactor, and a rugged embedded computer display, is easily installed on a vibratory compactor. When mounted on the asphalt roller, the IACA analyzes the pavement's response from the roller vibrations in real time, estimating pavement compaction while the pavement is still pliable in order to address issues relating to compaction. Density information from the final pass of the roller is used to compile the density of the pavement, and the color-coded map display is easy to read, enabling roller operators to view the information on the monitor and determine when adequate compaction is achieved. The results of the evaluation and testing showed that the IACA could estimate the level of pavement compaction with accuracy suitable for contractor quality control operations. The IACA can help improve the quality of asphalt pavements, increasing their life and reducing maintenance costs. It also increases efficiency and productivity on the job by reducing the number of conventional spot tests needed and excessive rolling. It takes the guesswork out of paving jobs. Construction of properly compacted pavements will result in a long-lasting roadway that does not require expensive, time-consuming, traffic-disrupting reconstruction and major repairs. For motorists, this means longer-lasting roads and a smoother, more enjoyable ride. For more information on the Intelligent Asphalt Compaction Analyzer and the Highways for Life Technology Partnerships Program, visit the Highways for Life website.
So you have seen the overall thing. This is exactly. I hope that the video is helpful. So what we are trying to do here is that we are measuring this vibration, and you get this sort of a cyclic type of response. So these are the steps that we follow here. So we record the vibration in real time. You can see that these arrows, and then you take that data in real time and put that through fast Fourier transform, FFT, fast Fourier transform, to extract the important features, the vibration features, right? And use that vibration feature in a artificial neural network, or neural network, ANN. As you know, that this is part of what we call is the, we all talk about now artificial intelligence. So this artificial neural network is one of the modeling tool using artificial intelligence. So so what happened, that this neural network, of course, you have to have the right data, otherwise it will not be able to recognize. So based on this, these vibration features, the neural network is trained, and I'll talk about the training or calibration in a minute. So then it knows that this particular feature, corresponds to this level of compaction. So these are all color coded. So this is what happens, right? You are measuring the vibration, you are putting that through fast Fourier transform, and through the neural network, which is trained. I want to emphasize that training is extremely important, and then it can recognize the level of vibration. So as it goes through the number of passes, it will. So this is what actually we have essentially, and the results of the level of compaction is displayed as you saw in the video in real time. Now there are a couple of terms that we use. That CCV this is the compaction. So this is a compaction control value. So that's kind of how, that's one of the parameters that some of these intelligent asphalt compaction machines they use, or CCMB. So this is the compaction control machine value, and things like that. So just I wanted to make sure that you're familiar with this technology, familiar with these terms actually. So essentially what is happening, that as you have seen in the video, that it records the vibration, and in the very beginning, and the first pass, that's called lay down, and then additional passes. So the very first pass is the lay down, and the machine itself, when it is laying the asphalt, that's what we call lay down density, and then additional compaction you receive through the vibration of the roller. And even after the asphalt is constructed, still some additional compaction happens from the vehicle, like big trucks and so on. So that's what you do. But in order for this technology to work, you have to calibrate. Calibration is the same type of thing. When we learn something, right? So our memory gets information about the new, data, new tools. The same thing is true for artificial intelligence, neural network. So this is what the calibration part is extremely important. So your knowledge is as important as whatever you have learned. So same thing, that the calibration, the quality of calibration will dictate, the output that you get from an intelligent asphalt compaction analyzer. So how do you do that? So in order to do this, you have to construct a test strip. So this is a test strip, and you take the actually reading on this test strip at every pass. Fast pass, you look at and then you take the density using, like, for example, nuclear density gauge, or there are even non-nuclear density gauge you could use also. So that's how you're measuring, and you're using the data to train. Also, you could train this using actual code. So in this particular case, you can see here that these are number 3, 2, 1. So this is where we're taking code. So that is, of course, taking code is a destructive process. So our goal is to minimize the actual code. So what will happen that as you do more and more construction and you are retraining this neural network model, it is becoming more and more powerful. Very same thing that as you learn new materials, you train yourself, your brain gets trained, and you become more experienced. So essentially, the same thing is applicable here for this technology. So this is the what happened. The software that actually uses is used to process the data is called VETA, VETA. VETA. So we collect the data, and this is this particular software, by the way, is you can use it. Anybody, you could download it. It's a free download. So that's what we use. We have used in our case, for processing the data. So essentially, what it does, this software, it takes a grid. The pavement is like a grid, and then it tells you the number of passes, what areas received what number of passes, 1, 2, 3, 4, like that, right? And then it also does temperature, roller speed, roller frequency, and it gives you the data results in as a pie chart. So I think this is very helpful because this software is already there. So in our case, I'm going to present only one as an example, right? So we have done it, for a number of projects actually with my students. So I'm going to actually cover only one of the projects, Highway 38 in Oklahoma. So how does it actually know the number of passes? It is based on latitude and longitude. So because we have GPS, right? From the GPS, it actually knows the latitude and longitude, which indicates the location of the roller, right? So you can see that it matches exactly latitude and longitude for first pass, second pass, and in the second case, it's a first, second, and third. So it is latitude and longitude are used as reference in this particular case, right? So one of the things that I think you can see here is that as you're constructing, right, the roller is operated by human being, right? And human being, even the experienced operator will still not be able to follow exactly same path. Maybe in future, you will have computer operated roller, and they will follow exactly the path you want it to follow. But in general, what will happen that the roller will be going off of the boundary that your actually construction boundary. So here, the red line is the actual boundary, and these are the different locations you can see. So in order for this thing to work, like what you want to do at the end, you want to find out what percentage of your road that you're constructing received one pass, what percentage received two passes, what percentage received three, and is your construction maintaining the quality and what the duty, in our case, like Oklahoma Department of Transportation, they have limits. So if you do a good job, you get bonus. If you do a bad job, then it is penalized. And our goal is to to help these companies so that they don't get penalized, they get bonus, right? So this is where it becomes a little tricky that you have a turn like this, as I have shown in this diagram. that you have to have the right boundary. That's it, right boundary, because otherwise your whatever results you get would not be correct, right? So that's one of the things that. So I want to show this example for Highway 38. That's one of the roads. This is a project overlay, type of project. This is the width is 16 feet. It's about 11,160 ton. This is a S4. The super pave makes S4. I think we can talk about this, uh, and Ashik may be able to even cover more in his presentation. It's a resurfacing job, right? Quite a little. Yeah. So anyway, you can see here the results. I think this is very powerful. You can see here that what is our target? Our Oklahoma DOT's target is at least all of the areas should get 2 passes, right? 2 minimum. And you can see that these are the passes: 1 pass, 2 passes, 3 passes, 4 passes, right? On particular day, October 4th, do you see that only 52%, only 52% uh, passes, receive 1 pass, 30%, 2 passes, and so on and so forth. So what will happen that sometime, and this is a good tool because it is good for the DOTs to also see whether the contractor is meeting the DOT requirement or not. And one more thing I think it is important to know in this, that you do not also want to over compact, because that also is not good, because if you over compact, there will be breakage of the aggregates and so on, right? So that would also not be good. So that's why I think you have to have a limit, and you can see that in some days the contractor met the limit, and other days they did not. So I think that this is why this type of tool, this is the type of pie chart you get from the beta software. So like this one day 98% covered, right, with 2 or more passes. However, the other day it did not. So for the same job. So if you do not have the quality that you're looking for, how do you expect this road to perform? I don't. So this is why this type of technology, and another important thing is that here you are able to actually correct your problem, because you are getting the result like this type of pie chart in real time, right? In real time. So you will have opportunity to go back and fix that. If you have only 1 pass and your target is 2, you look at the area that received only 1, and you can correct it in real time, which is very difficult because you cannot do this when asphalt has cooled down, you cannot change it. So the other thing is that also temperature. Temperature is very, very important, right? So DOT has a temperature requirement, minimum and maximum. So you can see here that in some days they did most of it, the temperature the requirement. This is again Oklahoma DOT. Bangladesh, I don't know. You could probably have some temperature requirement as well. So someday the temperature requirement was not met. Only 78% of the areas that are constructed, the temperature requirement were met. And this is the type of thing it also gives the speed of the roller, the standard deviation, frequency of the roller. So these are, I think, is very important. You can see here, I think they did a pretty good job overall, right? You want to keep this as uniform as possible, right? And that depends on, I do not know if any of you have had the opportunity to actually be on the top of a roller, like as you're driving the roller I did, it's very high. It's like you're riding an elephant, right? And it's very difficult job because you're placing asphalt when the temperature is very high. It's an extremely difficult job, uh, but I think they do a good job overall, I would say. And the frequency of the operating frequency of the roller, which is pretty uniform in this particular case. You get this type of results also. So I'm not so. Um, So basically, I think let me in this case you can see that the results overall dependability was pretty good uh, because this is difficult job, right? You cannot expect if somebody says that I got an R square value of 0.99, as Dr. Mizan said that I am the editor-in-chief of a journal. So when I get that type of paper, I actually laugh myself because that's not doable. So you can see here that our um, the actual compaction, the density, from the core versus the density as predicted or measured by our system here, IACA. And we got R square equal to 0.7. I think that 0.7 is good. You cannot get 0.9. That's impossible. So we have to be aware of that. So this is kind of we have done a lot of different projects. I don't think that there is a need to go through all of these projects because there will be different. It depends on the operator. It depends on, sometimes the mix quality could also be a factor because some mixes are relatively easy to compact and others are difficult to compact. So and also, I can tell you that there are different intelligent compaction technologies. I talked about the technology that we developed at University of Oklahoma along with Haskell Lemon Construction. So there are some of the comparisons. I'm not going to go over this, but I think I can make a copy of these slides available to you, so you can actually go over this yourself. I think this pie chart results are very helpful because that way then you can see where corrective measures are needed. So I have more of this type of thing that you could you could benefit from. I want to make sure that we have time, to have a dialogue, questions and answers, type of thing. So we have been working. So there's again, you can see that all kinds of, so, neural network is a very strange thing, right? Like any other model. Depending on what you are doing, right? If you like a regression model, for example, if you use regression model, so you divide your data into three parts. One, the first part you use to develop the model. The second one you use to sort of check or validate, and third one used, for prediction type of thing. So usually regression models are very good for the, if you look at the prediction of the data that you have used to develop the model itself, that makes sense, but not necessarily. So all of these tools have difficulty in terms of, so if you are doing interpolation, it's good. Interpolation is good. But if you're doing extrapolation, right, means the same type of thing that if you ask yourself, you face a situation that you have not seen before, then you'll think twice before making a decision. Same thing is true for these neural network and other models, right? And there are all kinds of model, random forest model, you just name it. So they are pretty good tools for interpolation, but not so good for extrapolation. So that's one of the things. So I'll share all of these slides with you. So overall, I think this technology, intelligent compaction, is very helpful because you are able to look at the quality of a construction in an overall sense that you cannot do with the existing technology, spot checking. So you're buying a shirt, but the shirt has a hole, but you did not look at that hole, right? That's the type of thing is happening here. So you have to have the DOT, like in here in Oklahoma, they have some standards, special provisions. We have to meet those, and if you meet those or exceed, then you get bonus. If you do not, then you get penalized. So really, our goal is to help both the Department of Transportation, they own our roads and bridges, and also the contractors because they are the one who do the construction, to help them. So we need to look at, and as I have indicated, that your boundary is important, that you have to look at your construction boundary properly. Otherwise, the percentage that we are talking about, 80% coverage, all of those things would be wrong, right? because it's a very simple thing. It's a geometry. So we have to define the geometry of a pavement properly, and then you can look at all of these, the compaction control value. You can look at the temperature. You can look at the frequency. You can look at the speed of the roller, and so on and so forth. This is one thing. The technology this technology was developed in collaboration with Professor Seshkomori. He is an electrical engineer. As you have seen, the Federal Highway Administration and this company, we also work very closely with the Volvo Construction. In fact, the technology was actually marketed by Volvo Construction Equipment, VCE. We work very closely with companies like Haskell Lemon, Silver Star, and so on and so forth. So let me actually stop sharing and go back to our screen so that you may have, I try to actually remain within my time, so that we have time for questions and answers. I personally do not believe in lecturing. I think it is more of a collaborative learning that I would like for you to ask me questions so that I can share whatever I know with you. But that's kind of my part of the presentation, Dr. Mizan. So I'm open for questions and answers. আমি তোমাদের সবাইকে encourage করবো to ask. I hope that that my message was, I can talk about this technology for a long time because we have we have been working on this for a long time. But I wanted to give sort of a snapshot of what this technology is about and why is it helpful. And many of you, I would like to believe Bangladesh is a wonderful country. We have a lot of talented people, but I think hopefully you will be able to actually contribute to this kind of thing. There is so much technological development happening right now. So civil engineering, pavement is not a low quality or low technology type of field anymore, right? I mean, it's a very technology. It's going to be increasingly more technology driven. So there will be compactor now in future that it will be self-operated, similar to connected and autonomous vehicle. I was actually visiting one of my colleagues' lab the other day, last week, and he essentially what he does, he buys vehicle, a car from a company, and I really mean it, and then he takes it apart, just like a surgery that you go to a hospital, you have surgery. He takes it apart, and then he makes it that vehicle autonomous. An amazing type of thing, right? I mean, taking a regular vehicle and converting that into an autonomous vehicle. So I had a ride with that. I was a little bit scared because there are some car parts. I thought that he was going to hit those cars, but he did not. And he was not holding the steering wheel. This is true, Ashik.
স্যার
So
আমাদের
I stop here.
না স্যার, আমাদের স্টুডেন্ট একজন, উনি প্রবাবলি স্যার স্টুডেন্টদের মধ্যে সবচেয়ে আর কি স্যার, উনি পিএইচডি করতেছেন। উনি স্যার আর্ম ফোর্সে আছেন, ব্রিগেডিয়ার জেনারেল জিয়া। ওনার হয়তো স্যার কোনো কোশ্চেন আছেন?
অবশ্যই অবশ্যই। So
জি,
please
আপনার
unmute. হ্যাঁ, yeah, জি, হ্যাঁ বলেন।
Sir, assalamu alaikum, sir. Thanks for a very wonderful presentation, sir. Actually, sir, I didn't have this sort of idea because I was also the project director of ENIT project, sir. You know, sir, ENIT project is from Jurain to Bhanga, sir. So one of the beautiful road in Bangladesh at present. I was the project director for some times of this project, and this system I have not followed. I can say you this thing. And also, if you see that the joints between the abutment and also the road, the compaction was not that much praiseworthy, because if you flow through, if you drive vehicle, you will find a jerk always. So however, sir, I have a question. Maybe I'm, as sir told, that I'm the senior most student of the course at present, maybe, inshallah. So I have a question that, sir, I understand the IACA, but how can the IACA optimize the asphalt compaction in real time to improve the pavement density and also ensure the long-term durability, while, sir, accounting the varying materials property as well as the environmental conditions, sir, because Bangladesh is, sir, you know, there's a rainy seasons, and also sometimes the winter is also long-term winter. So how can we really commensurate with the materials property and also the environmental condition? That's my question, sir. Thank you, sir.
So I think you have covered, your question is very broad, right? You have covered too many things. So I think it will take, I think as you know, that the quality of pavement depends on many factors, right? I have been working in this area for a long time. And as I said in the beginning, that whenever you try to address one problem, there are 5 new problems that come up. And I'm being honest. So in this type of case, it depends on. Uh, I just covered here only construction, right? Construction quality, only one thing, right? But it depends on the material that you are using. It depends on the design that you are using. What mixed design, like in the US, I think we are, and maybe Ashik, you can actually talk also about the type of work that we are doing in the mixed design area. And in the mixed design, we want to use, let's say, reclaimed material, because one of the thing is sustainability, right? We call it RAP, reclaimed asphalt pavement. And our goal is to actually increase the sustainability through the use of more RAP. And RAP has already the binder that are aged binder. So aging is a big factor. And the aging in Bangladesh will be very different than aging in this country. Your so it really depends on a lot of factors that you try to, and it depends on climate also. But I would argue that I know that Bangladesh receives a lot of rain. So does some of the other countries in the world. So we should not really think that Bangladesh problems cannot be fixed. So you talk about, like, for example, and you also talked about the bump at the end of the bridge. That's we have done quite a bit of work in that area also. That's a challenging topic though, because that problem has not been solved. Joint, for example, let's say when I showed you that the width of the roller is 8 feet, right? 8 feet, 9 feet, and the area that you're compacting is 16 feet, let's say. 8 times 2 is 16. Now, you cannot construct 16 feet at one time, right? So you have constructed 8 feet, and then you have compacted it, right? And then you're putting the second 8 feet. And what happens at that joint? Have you seen that in fact, we see that in Oklahoma all the time, that this maintaining joint density is one of the hardest things to do. So now they have different type of technology that they're thinking about, that instead of a vertical type of cut, you will have, sloping type of thing. So there are too many factors, General Jia, too many factors, right? So how do we address this? So my thinking is this, that first of all, to recognize that we have a problem. Unfortunately, in many times we don't recognize. We actually follow the status quo. So let's not follow status quo. Let's be aware of the tools that are available to improve. Like here, we talked about the construction quality. Let's make sure that we use the right material. Let's make sure that we have the right design, and make sure that we are producing the same, because there is also a difference between what the testing that I do in the lab, right, Ashik, and what you construct, what you produce in the plant, asphalt plant, and how far are you taking that asphalt materials from the plant to the construction site. There are so many factors that we need to take into account, and aging and so on and so forth. So I have not given you one answer, but what I am trying to say briefly is that this is a big problem. So first, that you recognize and I recognize that there is a problem, and then maybe we can have a protocol that, and it will be also an incremental thing. We cannot change things overnight. An incremental thing to make roads better. But I'm confident that if we do that, then the roads that we have constructed before and the roads that we'll construct in future, the future road will be better than what we have now.
Sir, thank you, sir. Thanks for your questions, answers.
By the way, we have done a lot of work in that. We call it, bump at the end of the bridge. I think that's what you talked about. I think my presentation today did not cover that particular topic, but there are, some solutions, for that problem also. So sometime, and I can mention one or two. So one is like using a select fill is one thing. Yeah, you also using sometime actually using um, kind of making sure a lot of time, I think the construction, again, the quality wise, we can talk about that. I think we have done a lot of work in that area, and there are different technologies and tools to address, that you talked about bump that you see from the pavement to the bridge at the junction.
স্যার থ্যাংক ইউ স্যার। স্যার আমার একটু মানে ঠিক কোশ্চেন না, মানে জাস্ট একটু জানার আগ্রহ আর কি স্যার, যে আমরা তো স্যার যখন আসফল্ট কংক্রিট লে করি তখন একটা প্রেসক্রাইব বা ডিজাইন একটা টেম্পারেচার আমাদেরকে ফলো করতে হয়।
রাইট।
তো এই যদি সেই টেম্পারেচারটা ভ্যারি করে তাহলে স্যার কম্প্যাকশনের উপরে তো একটা এফেক্ট তো আসে আর কি।
অবশ্যই।
সেই এই টেকনোলজি দিয়ে কি সেটা স্যার মানে অ্যাড্রেস করা যায় কিনা? আর
হ্যাঁ,
স্যার আরেকটার সাথে মানে আমি একবারেই মানে কিছু অবজারভেশন দিয়ে আমি স্যার আপনার কাছ থেকে জানতে চাচ্ছি। আর আর এখন তো স্যার আসফল্ট তো আমরা মেইনলি পেপার দিয়ে স্যার লে করি।
রাইট।
পেপার দিয়ে স্যার যখন লে করি অলমোস্ট তো স্যার 60-70% কম্প্যাকশন কিন্তু পেপার
অ্যাবসলিউটলি।
দিয়ে হয়ে যাচ্ছে আর কি।
রাইট।
সেটা কিন্তু মোটামুটি স্যার ইউনিফর্ম কম্প্যাকশনই হয়। তা আমরা এই টেকনোলজিটা স্যার যখন ব্যবহার করতেছি কোন রোলারে, মানে ব্রেকডাউন রোলারের সাথে নাকি স্যার ইন্টারমিডিয়েট নাকি ফিনিশিং যখন দেয় তখন আর কি ব্যবহার করতেছি?
এখানে ফিনিশিং হবে না, ফিনিশিংটা তো তোমার নন ভাইব্রেটরি নর্মালি ইয়ে করে আর কি, ফিনিশ রোলার। তো এখানে তোমার ইন্টারমিডিয়েট, মানে তুমি যেটা বলছো যেটা লে ডাউন ডেন্সিটি, রাইট? যখন একটা পেভার ইয়ে করছে এটা একটা লে ডাউন ডেন্সিটি, এবং আচ্ছা এখানে তো কম্পাকশনটা আসলে অনেক জিনিসের উপরে নির্ভর করে, রাইট? যেটা হচ্ছে একটা যেমন মিক্স টাইপের উপরে নির্ভর করে, রাইট? তারপরে নির্ভর করছে তোমার যে লে ডাউন থিকনেস, আমি কত থিকনেস, এই জন্য তুমি ইচ্ছা করলে 6 ইঞ্চি বা 7 ইঞ্চি 8 ইঞ্চি এরকম করা যাবে। ইনফ্যাক্ট রিসেন্টলি এনকাটের একটা ইয়ে ছিল, প্রেজেন্টেশন ছিল যে কত থিক এটা লেগ ইয়ে করা যায়। আমরা এটাও দেখেছি ইভেন ইন দ্য ল্যাব, যখন তুমি কম্পেয়ার করছো তখন ডেন্সিটি এট দ্য টপ অ্যান্ড বটম আর ডিফারেন্ট ফ্রম দ্য ডেন্সিটি ইন দ্য মিডল। এটা কিন্তু ল্যাবেরও আমরা দেখতে পাচ্ছি, যে ল্যাবেও কিন্তু এটা দেখা যাচ্ছে, রাইট? তো এটা তোমার তাহলে মিক্স টাইপের উপরে, যেমন আমরা একটা কোর্স মিক্স আমরা দিচ্ছি বেসে, রাইট? আর সারফেসে দিচ্ছি আমরা একটা ফাইন মিক্স, রাইট? তো তার মানে তোমার লেয়ার থিকনেসের উপরে নির্ভর করছে, মেটেরিয়ালের উপরে নির্ভর করছে, তুমি মানে হাউ মাচ অ্যাকচুয়ালি তোমার বাইন্ডার কতটুকু আছে সেটার উপরে নির্ভর করছে। অবশ্যই টেম্পারেচার ইজ এ ভেরি ডমিনেন্ট ফ্যাক্টর, রাইট? নো ডাউট অ্যাবাউট দ্যাট। টেম্পারেচার তো তোমার এই জন্য মেনটেন করতে হবে, কিন্তু এটাতে সুবিধা হচ্ছে কি যে তার মানে কোনো ক্ষেত্রে যেহেতু ইউ আর মেজারিং ডেন্সিটি ইন রিয়েল টাইম মেজার, তাহলে কখনো তোমার দুটো প্যাচ লাগতে পারে ওই ডেন্সিটি অ্যাচিভ করার জন্য, কখনো তিনটে প্যাচ লাগতে পারে, ডিপেন্ডিং অন দ্য মিক্স দ্যাট ইউ আর ইউজিং অ্যান্ড হোয়াট ইউ হ্যাভ below that pavement, because that also below that layer, that also is very important, right? যে তোমার যে so I think so those are the technology itself is capable, because as long as you have the right temperature though, right? টেম্পারেচার যখন ড্রপ করে গেলে কিন্তু ওইটা আর তখন কম্পেয়ার করা যাবে না। এটা ল্যাবেও আমাদের একই অবস্থা হবে। ইউ ক্যান টেক এ colder mix and then try to compact in the lab. You cannot, it will be very difficult. এবং আমি জানি না তোমাদের ল্যাবে, দিস ইজ ওয়ান থিং যেটা আই থিঙ্ক উই ডেফিনেটলি শুড লুক অ্যাট, যে আমরা ল্যাবে তো আমরা তো জাইরেটরি কম্প্যাক্টেড যেটা কম্প্যাক্ট করি, তখন আমরা দেখেছি যে ডেন্সিটি সমান না, একদমই সমান না, রাইট? আশিক, ইউ ক্যান অলসো মেক সাম কমেন্ট অন দ্যাট।
হ্যাঁ স্যার, মানে তিনটা কোর যখন স্যার কম্প্যাকশন করতেছে এক একটা ডেনসিটিতে এক এক রকম আসতেছে।
এবং ওই কোরের মধ্যে তুমি যদি টপ, বটম এবং মিডল নাও,
Middle,
সেটারও ডেন্সিটি ডিফারেন্ট।
জি। স্যার হ্যাঁ জি স্যার, এটা আমরা এই রোলারটা আমাদের এই টেকনোলজিটা আমরা আমাদের যে প্রথম ব্রেকডাউন রোলার যেটা সেটাতেই দিতে হবে, কারণ ওখানেই শুধুমাত্র ভাইব্রেটরি মোডটা ইউজ করা
অ্যাপ্লাই
হয়,
করা যায়।
হ্যাঁ অ্যাপ্লাই
হুম।
করা যায়। তো ওখানে এবং মোস্ট অফ দ্য কম্প্যাকশন আসলে ওই লেয়ারেই হয়ে যায়,
ওইখানেই হয়ে যায়।
ব্রেকডাউনের সময় হয়ে যায়। তারপরে সেকেন্ড আমাদের যে রাবার রাবার
রাবার
রোলার
কিউনেমেটিক
যেগুলো
ড্রায়ার
থাকে সেগুলোতে স্মুথেন আপ, এবং লাস্টলি ফাইনাল যে রোলারটা দেওয়া হয়, ফাইনাল ফিনিশিং রোলার, সেটাতে স্ট্যাটিক মুডে আর কি স্টিল ড্রাম রোলারটা ইউজ করা হয়।
Sorry,
তো
I meant to say breakdown. I think I misspoke. Sorry.
জি স্যার,
ইন্টারমিডিয়েট।
জি জি, এই টেকনোলজি কমপ্লিটলি ডিপেন্ড করতেছে স্যার হচ্ছে যে এক্সিলারেশন, আমরা যখন ভাইব্রেশন দেওয়া হচ্ছে তখন ভাইব্রেশনের সাথে ম্যাটেরিয়ালের রেসপন্সটার উপরে, ম্যাটেরিয়াল এবং যে কম্প্যাকশন স্টিফনেসের রেসপন্সের সাথে আমরা কিভাবে এক্সিলারেটর সেটা ডিটেক্ট করতেছে, এবং সেটা আমরা পরবর্তীতে আমাদের বিভিন্ন টেকনোলজির মাধ্যমে আমরা সেটা
স্যার
প্রেজেন্ট করি। সো
এটার উপরে তো
এক্সিলারেশন,
স্যার মানে আপনি এবং স্যার সৈয়দ আশিক, আপনারা তো স্যার অনেক কাজ করছেন, মানে এখান থেকে কি স্যার কোনো কনক্লুশনে আসা গেছে যে ম্যাক্সিমাম বা অপটিমাম কত ম্যাট থিকনেস দিলে মানে আমার কম্প্যাকশনটা স্যার প্রপার হয়, এরকম কোনো কোরিলেশন
Field
লিফট
কথা বলছি।
থিকনেস
ফিল্ডে আছে? ফিল্ডে
ডিরেক্টলি আমরা ওই ধরনের কাজ মনে হয় করিনি, কিন্তু সাধারণত লিফট থিকনেস আমাদের এখানে আমরা স্ট্যান্ডার্ড লিফট থিকনেসের উপরে গিয়েছি আর কি।
Right.
আমরা সাধারণত যেটা এখানে ফলো করি যে নমিনাল ম্যাক্সিমাম এগ্রিগেট সাইজের 4 টাইমস, ইট শুড নট বি মোর দ্যান দ্যাট। সো যদি আমরা একটা আমাদের নমিনাল ম্যাক্সিমাম এগ্রিগেট সাইজ হয় 1/2 ইঞ্চ, তাহলে লিফট থিকনেস শুড নট বি মোর দ্যান 2 ইঞ্চ। এই ধরনের একটা আমরা ফলো করার চেষ্টা করা হয় আর কি এখানে ওকলাহোমায়।
আমি জানি না, বাংলাদেশে তোমরা ওটা কিভাবে করো লিফট থিকনেস?
কিন্তু স্যার ওই ম্যাক্সিমাম নমিনাল ম্যাক্সিমাম এগ্রিগেট সাইজের উপরেই স্যার অনেকটা
রাইট,
ডিপেন্ড
এক্স্যাক্টলি।
করে। তারপরে স্যার যদি সে আমাদের 120 মিলিমিটার হয়তো টোটাল থিকনেস, তখন সেটাকে স্যার দুইটা লেয়ারে লে করা হয় আর
জি
কি স্যার, এরকম আর কি।
জি হ্যাঁ, আমাদের এখানে
Exactly.
জি 1.5 ইঞ্চ টু 2 ইঞ্চ ইজ ভেরি ভেরি
Common.
কমন লিফট থিকনেস এখানে ওকলাহোমা।
রাইট, এখানে তোমার একটা এই এনক্যাটের স্টাডি আছে যে ওরা দে ওয়ান্টেড টু অ্যাকচুয়ালি লুক এট দ্যাট আপার লিমিট আর কি, রাইট, যে ওটা কতটুক আপার
জি
লিমিট থিকনেস নিয়ে ডেন্সিটি রিজনেবল লেভেলে মেনটেন করা যায়। তো এটা দ্যাটস ইয়া, কিন্তু নর্মালি যখন কনস্ট্রাকশন গুলো বেশিরভাগ ক্ষেত্রে ওরা লিফট থিকনেস স্পেসিফাই করে দেয়।
জি জি
তো এখানে আই থিঙ্ক ইন দ্য ইন্টারেস্ট অফ টাইম আই জাস্ট ডোন্ট ওয়ান্ট টু টেক টু মাচ টাইম আউট অফ ফ্রম আশিক। এখন I think if it's okay, Mijan, maybe Ashik can, uh,
স্যার
Ashik, you still have 45 minutes because Dr. Mijan said that, you know,
হ্যাঁ
he has little flexibility time-wise.
স্যার থ্যাংক ইউ স্যার, থ্যাংক ইউ ভেরি মাচ ফর ইউর নাইস প্রেজেন্টেশন।
Thank you.
এখন আমি ডক্টর সৈয়দ আশিক আলী ওনাকে ইনভাইট করবো প্রেজেন্টেশনের জন্য। তার আগে আমি ওনার একটু পরিচিতি দিয়ে দিচ্ছি যে ডক্টর সৈয়দ আশিক আলী ইজ এ রিসার্চ অ্যাসিস্ট্যান্ট প্রফেসর ইন সিভিল ইঞ্জিনিয়ারিং at the University of Oklahoma. He received his PhD and MS degree in civil engineering from the University of Oklahoma in 2021 and 2016 respectively. Also, he served as a postdoctoral research associate at Oklahoma University for 3 years. He was a key team member for winning the funding for the Southern Plains Transportation Center, SPTC, that is a regional university transportation center led by the Oklahoma University. Dr. Ali has been working as a part of the core group that assistance managing and coordinating SPTC's overall work program. In addition, Dr. Ali has a lead number of external funded projects as PI and co-PI. His research projects have been instrumental in enhancing mechanistic understanding of performance and distresses of pavement, as well as developing guidelines and specification for Oklahoma Department of Transportation. Also, he has designated his research fundings, so presenting his work at different national and international conferences. His papers have been published in peer-reviewed journals with high impact factors. He has received several prestigious awards, including the University Gold Medal for the highest GPA in his engineering BSc program. He was named as a Dulce Fellow during his PhD study. Now I invite Dr. Syed Ashik Ali deliver his presentation.
Thank you very much. Thank you very much, Dr. Mizan sir, for introducing us, and also at the same time giving us this opportunity to present our work. Let me share my screen. Okay, let me see which one works. Okay, yeah. Is my screen visible?
Yes, visit.
Okay.
Visible.
Thank you very much for this opportunity. Assalamu alaikum, everyone. I'm Syed, basically, as Dr. Mizan sir already mentioned. I'm doing a research assistant professor at University of Oklahoma. I have been here for almost 10 years now, more than 10 years, working with Dr. Musharraf Zaman. We have this, I think Dr. Zaman did not introduce his center. We have the Southern Plain Transportation Center, which is a regional university transportation center. We got selected in 2022. We are getting funding for that center for like a 5-year center, around $3 million per year. We do lots of research, workforce development, and outreach activities. And Dr. Zaman is the director, and we all help him to run that center. So with that, I want to I will again, I will take probably around 30-35 minutes to present my work, and then we'll try to have a discussion on what we on the topic. My presentation today is on enhancing sustainability of transportation infrastructure using a forensic investigation. So the first part, the first presentation was on the construction side of it. Okay, construction, like how we can improve the construction. But as the discussion went on, we have seen that the durability, the longevity, and the performance of the pavement can deteriorate, or some pavement we have seen perform very well. So how can we actually find out why it is performing good, what is the cause it is not performing good, what are the contributing factors to that? So for those purposes, we do forensic investigations. And forensic investigation is to find out what are the problems and what has happened, and who is responsible for that problem as well. We have done a lot of forensic investigation over the years. There are many people involved in this forensic investigations, our whole group, but I just mentioned few names. Dr. Musharraf Zaman was almost the lead in every cases. I helped him. Kenneth Ray Hobson is our lab manager. He was also he is an expert. He worked for the Oklahoma Department of Transportation for almost like more than 20 years, and then he retired and came and joined our group. And he is a very good resource for this kind of study. And Shagor Ghosh and other students also helped us to do this work. Uh, Sustainable infrastructure challenges and opportunity. I think challenge in US we also have challenges. I know Bangladesh also have challenges. The first challenge is our aging infrastructure. Then at US, the infrastructure that we have right now is almost like 70 years old. The highway infrastructure was designed in 1950, 1960s and constructed around that time. So almost all the roads and highways and bridges, these are in very critical condition, aging wise. So we are seeing more and more problems, right? So as a result, to sustain this infrastructure, we need to come up with new technology, new material, and new ideas as well. At the same time, we are seeing increased magnitude of and frequencies of extreme weather events, flooding. I think Dr. Mizan sir was mentioning about flash flooding yesterday night. Like some amount of rain, 30 minutes, 40 minutes rain, it is flooded, the roads are flooded and everything. So how that is going to impact our pavement, our infrastructure? If we know, that is the first thing that Dr. Zaman taught me when I came here. The enemy of the pavement is water, right? Water. Enemy of the pavement is water. So if you can take water out of your pavement, you can have like a good pavement. So, but the same thing, we also have flash flooding problem in Oklahoma, hurricanes, drought, fire, extreme variation in temperatures. This is becoming very significant nowadays. In daytime, you may see like a very high temperature. At night, temperature goes down significantly. The difference between day and night temperature may be 30 degree, 40 degree, 40 degrees, whether it is in Celsius or Fahrenheit. But just see the magnitude of difference, how what your body is going to react to that kind of change, right? The same thing is going to happen for the pavement, our infrastructure too. So that type of extreme variation in temperature is also impacting our pavement, our pavement and other things. Also, at the same time, as I told you, like our pavement infrastructure was designed in 1950s, 1960s, considering the traffic and technology that they have around that time. But is that traffic, the traffic load, the vehicle type, the same after 70 years? No, it has changed significantly. The loads on the truck has changed, the tire pressure has changed, everything has changed, but our infrastructure is the same. So we need to consider those things as well. Also, at the same time, if the problem is, another problem is the funding, money. Nobody has enough fund to fix all these problems. And another problem is not having trained workforce. It's not enough engineer, not trained construction workers and other stuffs. So including all these problems, our infrastructure is in jeopardy. We are seeing more and more problems as we go. But challenges will always be there. We should not just get depressed with the challenge. It comes with opportunity. We take this as an opportunity. Whenever there is a challenge, problems, we see this as an opportunity to work on new materials, new technology, new innovative designs, maintenance practices, and stuff. So that's the thing I like about a forensic investigation as well. So through forensic investigation, you can understand the problem, and at the same time, you get to use new technologies that can help you to resolve those issues. So role of forensic investigation, I think I already kind of touched on that. Determining the reasons for poor pavement performance. Also, at the same time, understand why some pavements are performing exceptionally well, right? So if we can find out that, then probably we can just replicate that on other projects and get benefit of that. Also, sometimes collecting specific project data for maintenance, rehabilitation, reconstruction purpose, sometimes for litigation purpose. Okay, if a contractor does a poor job and the city wants to find out, okay, who is responsible for that, and there may be some litigation going on. So one of the party may come to us asking, okay, can you find out what happened and give us an expert opinion? So for settling disputes, we sometimes try to do that too. Also, collecting some general data that also helps with some pavement design models. As we know, right now we previously our pavement design was mostly empirical, but nowadays it has become more mechanistic empirical. So when we are talking about mechanistic empirical, there are different models that try to correlate between the distresses and the loads and the pavement materials and other steps. So to do that calibration, we also need to do some like a data collection. Forensic investigation can help on that regard too. So the ultimate goal is to have a sustainable infrastructure. So here is a book, the NCHRP report that generally we follow, NCHRP report 747. This is the very good guidebook for doing any kind of forensic investigation. It works very well for USA. I believe it can be it will work for Bangladesh too. If any of you are interested, please try to use that. So here we are seeing some different tools. So the thing I like about forensic investigation is that there are some research component to it, but not very heavy research oriented. But at the same time, you get to use new different tools. Okay, you can to find out what is the problem, what is causing that problem, and also who is responsible for that problem. So you get to use new different tools, and I'm going to show you some different technologies that we have used for forensic investigation. So my goal today here is to present two case studies. I'm not sure how much I can cover. I will go over the first one, and the second one will just show you few things that will probably like help you to understand what are the how we can do forensic investigation and what are the tools and technology we use. The first one example is US 412. This is in District 4. So Oklahoma is divided, Oklahoma DOT divide the whole Oklahoma in 8 different districts. So this is in District 4. This is around the northern side of Oklahoma. This US 412 is a US highway road, a major highway road. So they have found, the Oklahoma DOT, Department of Transportation, they have found that it is showing extensive cracking. And that extensive cracking has extended for around 7 miles of that road, 7 miles of that road. And also, like when we went there for preliminary investigation, we have seen that there are significant cracking, as you can see in this pavement. You can already see there are cracking, there are some rotting, there are some block cracking, significant rotting on the wheel path, major problem over there. Okay, so they want us to find out why this is happening and what can be done to get rid of this. Okay, so any idea, anyone, why this is happening? From your pavement design class, probably you may have discussed about these different types of pavement distresses and why each of these distresses might have happened. Anyone wants to take a shot here?
Temperature and shrinkage issue.
Temperature and shrinkage. Okay, that's a good guess. Yeah. Anyone else?
Excess load.
Excess load. Yeah, that's a good one too. Anything else?
Drainage may cause also.
Water intrusion.
Water intrusion and drainage. That's very good. Anything else?
Anything else?
Temperature cracking, sir.
Of
Temperature
cracking.
Okay, I think we got different options here: temperature cracking, temperature variation, then water intrusion, and another one was load, excessive load, right? Okay, so that's very good. Those are very good assumptions. Let's go over this. Okay, let's go over this and let us see what we have found through our investigation. Okay. Okay, so this is the area. This is the general area. This is the Google Earth image. Generally, when we have this kind of problem, we first thing we do, we try to have a visit to the road, drive the whole thing, find out see what is the extent of the problem, how far it is, and is it consistent all through or not, or is it a more localized? So we try to do that. Also, we use Google Earth image sometimes. Google Earth, if you go to Google Earth, it can give you year-wise image as well if they have that in their database. So that also helps us to find out where there is any significant difference in those distress that we are seeing. Okay, so that's one way to do it. We did not directly follow that path here, but we try to find out. We use the Google Earth to find out the best possible location for doing the further investigation or more detailed investigation. So we find out this is the whole area that is showing the problem. We kind of for test site, we selected a 2,500 feet long test site somewhere. I believe it is somewhere around here. Okay, and we also at the beginning, what we try to do, we try to collect all the document that is available at DOT level, like if the construction document, as-built construction, or any other design document that they have. We have found that in 2006, the ADT was 5,500, and the road was designed for 6.7 million e-cells, which is pretty normal, pretty good e-cell value. But with that e-cell, it should not crack, because what we have found, the document we have found, the original pavement was there from 1969, more than 50 years. Okay, more than 50 years. So that's good. It has been serving. But what DOT was doing is that they were, whenever there is a problem, they were going there, they are taking the 2.5 inch from the top, and they're putting a new 2.5 inch over there. Okay, so that's what they were doing for quite some time. They were not doing any any major rehabilitation work on this pavement. They were just doing what we call it is a milling and filling. Okay, they're milling few portion, the top portion, top surface, and then filling it back with a new mix. So the last dust milling and filling was done around 2009. The design was done in 2006. Then they did this overlay around 2009, which is still 10 years. Generally, overlay last 10 years, more than 10 years. But they started seeing this, like although like they came to us more than after 10 years, but they are seeing this problem much before. Okay, so that's why they are more concerned, like what went wrong with this construction work. Okay, so we went there, we did we spent a whole day on that pavement. We closed the outer lane of the pavement around 2,500 feet, and then did like coring and lots of other things we did. So from that coring, we have found that when we did the coring, we take out the core, we found that we have this, they have this 2.5 inch on the top, which is the new overlay, 2009 overlay. Then they have a variable thickness base asphalt layer, which was spent from like 5 inch to 12 inch existing pavement. And underneath that, they had around 8 inch to 9.5 inch asphalt treated aggregate base. So here we call this asphalt treated aggregate base. Actually, we call it hot sand. This is a mixture of fine aggregate and some amount of asphalt to stabilize that aggregate. So it acts as like a bounded material, not an unbounded material or granular material. So we're going to see some picture of that. And obviously underneath that, we have their compacted subgrade. Okay, so that's the whole structure they had. So what went wrong? So to find out what went wrong, we did, we as I mentioned, we went there, we closed the lane, we took out aggregate, we took out asphalt cores. We also took out some soil sample from those cores, and we did a bunch of testing on those. Okay, bunch of testing, and we tried to cover all the spectrum of testing because we did not know what actually happened there and what might have been contributed, right? So as you were all gazing, there may be different factors that have contributed, right? Okay, and this is the list of tests. I don't want to go over all those, so I will try to explain those when we do go through the results of each one of them. Okay. Okay, so are you familiar with FWD here? Falling weight deflectometer. Anyone has experience with FWD? So falling weight deflectometer. So this is a non-destructive test. What it does is it goes, if you want to know the modulus of your pavement or the pavement different layers and stuff, or how strong your pavement is at the current condition. So this is the falling weight deflectometer. You take it there, it drops a load on the pavement surface, and there are some LVDT, okay, deflection LVDT, that reads those deflection from that load. Based on that deflection, load and deflection, you can determine the stiffness or modulus of different layers, okay, of your pavement. So we use that device, the falling weight deflectometer. I think I have a picture over there somewhere at the very beginning here. So this is the falling weight deflectometer. So this is the load, and there are some like around 6 to 7 sensors that reads the deflection. So there's the impact load. It puts the impact load around 7,000 kip. Sorry, 9,000 to 12,000 kip impact load, and then it reads it. And from that, you can actually back calculate the stiffness of your pavement, different layers of your pavement. Okay, so we contacted a company and they did the falling weight deflectometer throughout the pavement. Around 20 FWD test was done at different points, and these are the results. Okay, so deflection of the point, the normalized W1 deflection, which is just underneath the load. So this is the deflection of that, and from the deflection we calculated the modulus of different points, different location of that test section. So what we have found, the deflection was pretty high. Okay, the deflection, W1 deflection that we found was pretty high, and also the modulus value was, the average modulus value was 121 KSI. Okay, KSI, kip per square inch, kips per square inch. So in US we generally go with the FPS unit, feet pound second, right? So this is kip is 100 times of pound, 100 times of pound. So generally, if the pavement is structurally sound, the deflection should be less than 0.01 inch. And the modulus value should be around between 400 to 500 KSI range, where we have seen very low, right? 121 KSI. So that actually to tell us, okay, now this pavement is not structurally adequate. The modulus value is very low. Okay. So we also try to find out the extent of the problem, okay? Which whether the cracking, rotting that we are seeing, is it like all through the test section, or is there any like and how bad it is, how bad the cracking is, how bad the rotting is, how bad the IRI, International Roughness Index is. So for that, we use this equipment, this vehicle. This is called the PAVE 3D 8K. So our sister university, Oklahoma State University, they have developed this technology. This is a laser-based technology. It runs at highway speed and it shoots laser on the pavement. And from that, it can actually map your pavement, map the pavement surface. It can make a 3D model of your pavement surface. And from that, we can calculate how much area is covered with cracking, how much area has how much is your rotting, how much is your IRI. We can get that from that vehicle. So this is a very neat tool, and they have been working on this tool for quite some time now. And they can actually see very like a micromillimeter crack through that laser device. Okay. So lots of research has gone on to develop this thing. So we have found that the pavement IRI is very high. Around 568 is the highest number we have found. Whereas generally, if it is more than 170 inch per mile, it is considered very bad. So very significant distress on that pavement. So that pavement is not in any kind of in functioning condition. Rotting is also, in some places we have found rotting around 1 inch rotting. Generally, the accepted range is half-inch rotting. So this is also not acceptable at all by Oklahoma DOT standard. Okay. Then, okay, we wanted to find out what actually happened. Okay. And as you can see, we cannot see underneath what is going on underneath, right? The pavement is the first thing is that like we always we found it difficult. What is actually what is the condition underneath the surface, right? We do not know that. So the subsurface condition, looking at the subsurface condition is very, very important. So we have found that using ground penetrating radar is a very good tool to look at the underneath what is going on at the bottom of the surface, right, on the subsurface, and whether actually we are seeing some cracking, rotting on the top, how much it is extended. Is the whole pavement layers has been like this, or is there any problem on the subgrade that is actually reflecting on our pavement? So we wanted to see that here. So ground penetrating radar is a very good tool for that. So how do we do it? We ran like a GPR on the transverse direction and also on the longitudinal direction as well, multiple times. Okay, on the wheel path, non-wheel path at different locations to see the extent of this problem. So we have seen. So this, so just look at here. So here in this, sorry, here I think can you see my mouse? I think you should be able to see my mouse now. So this here, the asphalt is all, the pavement layers are all disintegrated. Okay, it has collapsed. Almost nothing is there. No structure there. Okay, it happened because of some bottom-up cracking, and the cracking is going from the bottom to the top. Also here we are seeing some top-down cracking is coming down. Crack has happened on the top and it is coming down. Crack has happened at the top, it is coming down. So this pavement has bottom-up cracking, it has top-down cracking, and also if we look close, so this is your subgrade. This is a subgrade. Here we have our subgrade, and on the top we have our surface layers, pavement layers. The subgrade looks fine. There is almost no problem, no deformation on the subgrade. All the problem we have is on the top layers. Okay. Another thing we have seen is that these lines are actually showing some delamination. Delamination means the interface between different layers are has been separated. Okay, for example, here. So this is the top 2.5 inch of asphalt. This is the existing asphalt. So when they did the deconstructed that, it did not bonded well at the interface. Same thing is here too. We have found that there is some stripping. The delamination is fine, but there is also some stripping. That means moisture intrusion and aggregate has come out. There are some delamination over here too. Okay, so there are different layers of delamination. So when we see delamination, that means there is no contact. How the load is going to transfer, right? The load transfer is not 100% here. Okay, when you have this interface problem. Okay, so major things from GPR: delamination, top-down cracking, bottom-up cracking, and also we have seen there is no disturbance on the subgrade. Okay. So that's a good thing. And also we did the same thing on the longitudinal profile as well. We tried to find out the longitudinal pavement to see the extent. Okay, is it more localized or is it almost everywhere? So the test site that we have selected, almost everywhere we have seen like a disintegration and the underneath layer of the pavement, and delamination is all through the pavement layers. Okay, in all cases. The wheel path, and also in the center of the lane means this is the longitudinal non-wheel path locations. Wheel path has more disintegration than the center lanes. Okay, so the core we took out. We also wanted to see the core, as I have already mentioned. We take out the core. We will see like what is going on. Obviously, we have seen delamination, some moisture intrusion and stripping. You can clearly see it from here. So there is some moisture problem, obviously. And also we try to look at the using a camera. We try to find out like is all the cracks, like is it top down cracking or bottom-up cracking, because top-down cracking has different mechanism than the bottom-up cracking. Okay, anyone can tell me like why, what is the mechanism for top-down cracking and what could be the mechanism for bottom-up cracking? Any idea why we may have bottom-up cracking?
Moisture
Sorry,
Due to poor binder selection, sir.
sorry.
Maybe due to the poor binder selection.
Poor binder selection. Yes, yeah, that could be. So I'm talking about the mechanism. So why we see bottom-up cracking? Like, so see, this is my pavement, right? This is my mobile, but let's consider this is my pavement. So when we the wheel loads are loads, right? That is applying a load, right? Wheel truck and everyone is coming. This is applying a load. And then if your pavement layer is like this, it will try to bend in flexor, right? Your pavement will the layer will try to bend in flexor. So when that happens, you're going to see tension at the bottom of the asphalt layer and compression on the top of the asphalt layer, right? So because of the tension, if the tension is too much, then the bottom will crack, right? And then with more and more track loads, more wheel loads, that crack will open up and it will try to propagate from the bottom to the top. So that's the bottom of cracking, right? So that's because of the fatigue or less flexural strength of your asphalt layer. But at the same time, the top-down cracking has a different mechanism. Top-down cracking is generally because of your poor binder, or if your binder is more oxidized, the asphalt layer is too stiff, that the cracks, it becomes stiff and brittle, and crack started from the top and it propagates from the top to the bottom, right? So two of these has completely different mechanisms. It is important to understand whether your crack is happening from the top or it is happening from the bottom, right? So here actually the pavement was so bad, the crack, we have seen top down cracking, we have seen bottom up cracking, and in some places the top down and bottom up crack actually connected to each other and completely disintegrated the pavement. So here, so we actually take out the top portion and we have seen, so this is the bottom up cracking. It can generally, like if you take the top portion out, so this is the way it propagated from the bottom to the top, right? When I was mentioning that the top and bottom crack, when they connect, that pavement section completely disintegrates. So this is what happens in one of the core when we are trying to take it out. completely disintegrated. So there is almost no structure left on this one. Okay, so completely disintegrated. Okay, I think so. After inspecting the asphalt cores, we generally try to find out the thickness of different layers and also thickness of the asphalt cores, and try to physically try to find out whether there is a delamination, stripping, and what type of cracking we are seeing there. Okay, so these are the general conclusion we got from the physical observation. Although like GPR showed us there is not, or maybe not much problem on the subgrade, but when we were there that day when we were doing the investigation, we thought to do like get whatever data we can. We also, that's why we did some subsurface like subgrade investigation as well. We ran a DCP over there and found out that the CBR value, or the modulus value of that soil, as you can see, we did a core, and then we just did the the DCP test on that core, on that soil layer. Modulus we found around like 20.1, or like average was 14.7, which is pretty like good for a soil which is A76, A75, A76, which is like a clay soil in Oklahoma, very common subgrade soil. But for that soil, 15 KSI is very good subgrade resilient modulus. So we are okay with that. So we can see that like a good subgrade support we have over there. Also, around the same time, we did another equipment it is called the seismic cone penetration test, SCPT. So seismic cone penetration test, it also gives you the friction tip resistance, and also it helps you to understand the N value or the bearing capacity of the particular pavement section. So we did that using a company. We contacted a company and they help us to do that seismic cone penetration test. Generally, seismic cone penetration is not done for pavement purposes. Generally, more like if you are doing a breeze, if you want to investigate the geological portion more, then you do that. But even from this test, we have found that like actually the moisture state on the soil is critical state. So the pavement is there for 50 years, right? So it has sustained for 50 years. So subgrade has stabilized. The subgrade is not moving. The moisture and the soil layers, that there is not any more interaction left. So that soil has reached a critical state, and with a good strength as well. So stiff compacted subgrade soil, and N value was pretty good. So we have concluded that soil is not the problem. The problem is on the top layers. We did this sulfate test sometimes on the soil because we have found Oklahoma, in some places in Oklahoma, there are some sulfate problem. And when you have sulfate problem, and if you use any kind of like a soil stabilization, like lime stabilization or cement stabilization, it expand. Okay, there is a chance of expansion of that soil. So presence of sulfate is very, very important to understand whether you have sulfate or not. So we did that test just to make sure, just to like take this thing out of our mind, like there is no sulfate problem, and we have seen that. So that area does not have any sulfate problem. The sulfate values or ppm is very low. The acceptable range is less than 8,000. We got around 120, 140. So we are not worried about the sulfate as well. Okay. Now, when we get the core, we took the top portion out, cut the top portion, we determine the density of it. Okay, so now here comes the actual reason why we are seeing this problem. The road generally in Oklahoma, the target density is 92 to 94% when you construct it. Okay, so Dr. Zaman mentioned about the construction side of it, how we can make sure we have enough density, right? When they construct this, the target should be between 92 to 94% density. After 10 years, when we went back, took out the core and found out the average density on the top layer is 92.7 average density, but in many cases, it is lower than 92%. Generally, after 10 years, we can expect to have a density around 95% or more than 95% because 10 years of traffic should be able to compact it enough, right? So that could be a big problem. Maybe they were not able to compact it to the right amount, right density they wanted to do, right? So that probably one of the problem. We were expecting more than 95%. We are seeing around 92%, 93%. So obviously, if your density is not good, then your pavement is not going to perform well. It will not be durable. Also, we did some testing to find out what is the current condition of cracking resistance. We did some testing called Illinois Flexibility Index test. If the value, and it gives a value of Fi, if it is less than 8, it's good. If it is more than 8, it's bad. Okay. Sorry, if it's less than 8, it's bad. If it's more than 8, it's good. So we found the very minimal Fi value of the top course are very minimal. So there is no way this asphalt mix can sustain any kind of cracking. Also, we took out the core, we take out the binder out of it. We extract the binder, asphalt binder, out of that core. Okay. And we did some grading, find out what is the grade of this, how oxidized this material is. Generally, in those kind of pavement, we use a material which has a PG of temperature of 64 degrees Celsius or 70 degrees Celsius. That's natural. When it gets oxidized, the PG temperature goes higher. Here we have found the PG temperature is 112.3. So that pavement has been oxidized significantly. That's why we are seeing those top-down cracking as well. Okay, oxidized significantly. So overall, as you can see, the subgrade was good. So and also we did some rotting testing to find out the rotting resistance and we found that the rotting resistance was pretty okay. That the pavement was not that much rot prone, but because the cracking has happened, that has led to the more and more rotting of the particular section. Okay, so this is the ultimate conclusion we had. So we have found the subgrade was not responsible for it. Binder was highly oxidized, so we requested ODOT to look at that, to what binder was used and how the construction was done. Delamination and stripping has been done. So now think about what should be done in the future. How we can rehabilitate this pavement. Okay. If we want to see what should we do on this pavement, then we need to find out what is the extent of the problem, right? We have seen delamination in almost every layer. We have seen stripping in almost every layer. So that's the problem. So that means we need to do something about that. Resistance to rotting was pretty good, but cracking actually leading the problem here. And pavement is severely cracked. Okay. More cracking is expected, which could damage the subgrade. So as more cracking happens, the extent of the problem will go down, and the subgrade can be affected with time. So we kind of what we do, we do not give a one solution to DOT. We generally give a recommendations of a number of things. We from least cost to most cost. Okay. The least cost was to just go ahead and do whatever you are doing, do a mill 1.5 inch and fill 1.5 inch back with a S5, which is very fine mix, with PG70, which is a little bit stiffer asphalt mix that will help to give the strength. You can do, if you have a little more money, you can do the next option. If you have enough money, our final recommendation was go ahead and take out the whole asphalt section out and do a complete rehabilitation, full depth rehabilitation of that pavement. Okay, so that was the and this is the way they should do it. Have a 4 inch of S4 PG70 and 5.5 inch of S3. So this is kind of at the end we give them this recommendation, and then it is up to the DOT, Department of Transportation, to whether which options they think is viable for them. I don't want to go. I think I'm running out of time. I don't want to take go over my second case study here. But one thing I want to show is, as we move forward with the forensic investigation and other things, we are trying to incorporate new tools which are more non-destructive and at the same time helps us to reduce the amount of time needed. Okay, we are trying to find out the tools that can and also less traffic disruptive as well. Okay, for example, in our last case, we had to close down one lane for the whole day, and we had to divert the traffic do our work. Okay, we have field crew over there, we have traffic control guys over there. Otherwise, these are very heavy trucks going at 60 miles, 70 miles, 80 miles per hour. Okay, it is a very dangerous situation to have crews on the road. So what we are trying to do, we are trying to come up with less destructive test method, and also we're trying to find out whether we can get more. We can have equipment that can collect data at traffic speed, so that we do not have to have like close down the lane. They can just run with the traffic and collect data. So this is one of the tool that we have used in another one. This is called a ground, although like it is a ground penetrating radar, but it is developed by Texas Transportation Institute, TTI, which is one of the biggest transportation institute in the whole world. They have developed a equipment GPR, 1 gigahertz air coupled GPR, but you can run it at highway speed, 60 to 70 mile per hour, and collect data at the same time. No traffic control is needed. Okay, so you can just do it any day. Okay, go there, run the vehicle and collect data. Same results that we got on the previous one. So that's one tool that we have used with TTI very significantly. I don't want to go over this. I just want to introduce you to another tool, which has come out very recently, which is a replacement of the of the falling weight deflectometer. Is called traffic speed deflectometer device. So if you just search by traffic speed deflectometer, there are lots of work going on right now. If you are interested, please look at this. Again, same thing. You do not have to close lane. You do not have to have crew on the pavement. Just run this. This vehicle is equipped with all the equipment it needs. It runs and it collects data, falling weight data, deflection data as it runs, and then from that we can actually analyze. We can find out the deflection value. We can find out the modulus of each of the lanes and everything. So that's one thing that we are actually currently working on this device a lot. If you are interested, please just search by traffic speed deflectometer. You will get a lot of information. I think with that, I will stop. I don't know. I hope I was able to contribute a little bit to your knowledge. And if you have any questions, I will be happy to answer. And I'm sorry, I take I think 10 minutes too much.
No, it's okay. Thank you,
Thank you.
Dr. Syed Ashik Ali. স্টুডেন্ট তোমাদের কারো কোনো কোশ্চেন থাকলে তোমরা আমার কাছে তো খুব ইন্টারেস্টিং লাগছে আর কি।
জি
বিশেষ করে যে আসলে যেই স্টেট অফ আর্ট যেই ইকুইপমেন্ট গুলো ব্যবহার করা হচ্ছে,
জি
আমাদের এখানে আসলে সেই সুযোগটা তো আমরা পাচ্ছি না আর কি, যে কারণে আমাদের ইনভেস্টিগেশন গুলো মানে প্রপারলি কি রিজনটা আসলে আমরা আইডেন্টিফাই করতে পারি না অনেক সময়।
জি জি জি
সেটা হয় আর কি।
Ashik, এখানে মনে হয় Dr. General Jia has some questions, I think.
জি
Sir, thank you very much, sir, for allowing me for question, sir. Sir, first of all, I like to say that today both the classes was excellent, like anything, and really I like to say my heartfelt thanks to Syed Ashik Ali for his wonderful presentation. It's really
Thank you.
because I have a experience in working on the ground due to my service experience in the field. So I understand many things. Maybe I'm not knowledgeable like the students here or everybody, but I have a field experience in working with the roads and also the culverts, bridges, and also the other works. So I
Yeah.
find this today's presentation was excellent. Both Dr. Musharraf, Zaman, and also the Syed Ashik Ali. Really, it's
Thank
fantastic.
you.
It's really fantastic. And also I could learn many things today. So I really want to say my heartfelt thanks and gratitude both the professors for their wonderful presentation. However, I want to share one thing with you. It's not the question, maybe it may be discussion. If anybody can mark, before 3 to 4 years back, the Dhaka-Chittagong road was damaged severely. I mean, the cracking and also the rolling, pitching, so many things. I mean, at the middle of the road was just a road, and also the axle area of the high axle area of the vehicles, I mean the heavy vehicles, it was go very down. I mean, the difference between the top and also the bottom was almost 6 to 7 inches,
Oh my
maybe
goodness.
more than that in some places. So what I found that they have just removed the upper portion by milling, and then again they have put the pavements, I mean all the asphalts over that. But the things I learned from Syed Ashik Ali, it was not followed. So really I mean the quality control was not done that much,
Yes,
if I'm not wrong. So
yes,
actually my assessment is that if we could follow the system of the all the I mean the new dimensions, also the new technologies, I think we could do it more earlier, more easier. Like
Yeah.
you have at the last you have shown that by the cost and estimation.
yes,
If
yes,
you can go for milling of the 2.5 inches, that's good enough, and it may remove all the cracks and make the road very passable. At the
yes,
same time, if you have the money, then we can go for 9.5 inches milling
yeah,
and removing of the road surface, and then we can go for the again pavements and other things. So,
yes,
however, um, my assessment is that if the fatigue crack and also the thermal cracks, this also happens on the road, then how actually this forensic investigation really help us to solve all the problems of the pavements. Thank you, sir.
Thank you very much. Thank you very much for your kind words. Thank you.
So one thing I wanted to also make a statement here that one of the benefit of forensic investigation, as Dr. Syed Ashik Ali has indicated, is that will avoid making same mistakes again and again.
Yes.
Because at the end of the day, I think you are paying for it anyway. So if we know that these are some of the major problems, and then if you can sort of address those problems to the extent it's doable, then I think you will have better roads, longer lasting roads, and the cost will still be the same or less, right? So this is something I think we need to keep in mind. The other thing is also important through this, Ashik's presentation, is that there are different tools and technologies, right? Particularly the traffic speed deflection device. That's a pretty expensive one, but very helpful,
Yes.
right? Because you are not only looking at the pavement surface problems, but also what is happening under uh, in different layers without stopping the traffic. The traffic, of course, in Bangladesh, even in this country, traffic is a big problem, very big problem. In US, we lose about 40,000 lives every year, 40,000 plus, right? And our goal is to actually, bring this to zero. That's what we call Vision Zero. So I think so. These new technologies, um, I don't know, Mijan, you may want to check whether Bangladesh, as some of these countries. So this is an Australian technology, but developed in collaboration with Europe. Uh, whether that type of thing can be used or not, or even the other thing that you talked about, falling weight deflectometer, or even GPR, right? That is the ground penetrating radar. This is called air coupled GPR. That also is a very good tool. And uh, uh, I don't know. I think it is. We have to be willing to learn new methods and be willing to use new tools if we have to make any progress, Mijan. So
Sir.
that's kind of my honest and humble opinion that maybe as we move forward with our conference, maybe we can actually also bring in people from that who are developing or using these tools and share their experience. So why Bangladesh would not be willing to take benefit from this development, benefit from these tools and technologies? Uh, I think that would be great opportunity, honestly.
জি স্যার। স্যার
Thank you, sir.
ফরেনসিক ইনভেস্টিগেশনের জন্য আমরা স্যার মানে খুব বেশি যে মডার্ন টুলস বা ইকুইপমেন্ট ইউজ করতে পারি আসলে তা না। আমরা মেইনলি দেখা যায় যে কোর কাটিং করে কোরের উপরে যতগুলো
Right.
টেস্ট করা যায় সেখান থেকে কিছু কনক্লুশন ড্র করা। রিসেন্টলি স্যার আমরা হয়তো কিছু জিপিআর আমাদের যে রানওয়েটা স্যার মানে ঢাকা
হ্যাঁ,
এয়ারপোর্টের যে রানওয়ের ওভারলে
Right.
করবে সেটার এক্সিস্টিং কি কন্ডিশন আছে সেটার জন্য আমরা স্যার জিপিআর ব্যবহার করার ইচ্ছা ছিল, কিন্তু স্যার এটা একটাই ইনস্ট্রুমেন্ট ছিল, সেটা আবার মানে নট ওয়ার্কিং প্রপারলি। ফলিং ওয়েট ডিফ্লেক্টোমিটার স্যার আমরা ব্যবহার আহ, করে কিছুটা স্যার ই করার চেষ্টা করেছি। আর বেশিরভাগই স্যার আমরা ওই যে কোর কাটিং এর উপরেই আমাদের ডিপেন্ড
রাইট, কিন্তু
করতে
মিজান
হচ্ছে।
কোর কাটিংটা তো তোমার ডিস্ট্রাকটিভ মেথড, রাইট? তো এখানে জিপিআর কিন্তু খুব এক্সপেন্সিভ না। ইনফ্যাক্ট আশিক ডিড নট হ্যাভ এ চান্স টু টক অ্যাবাউট, আমরা একটা পেপ স্ক্যান কেনার চেষ্টা করছি আর কি, যেটা ইজ, আমি অফকোর্স এটা কস্ট, প্রত্যেকটা জিনিসের একটা কস্ট আছে,
Cost আছে, জি,
কিন্তু তার বেনিফিটও কিন্তু আছে আর কি, রাইট? যেমন পেপ স্ক্যান দিয়ে তুমি তোমার এগেন কোয়ালিটি, দিস ইজ অ্যানাদার টুল টু লুক এট দ্য কনস্ট্রাকশন কোয়ালিটি। তোমার জিপিআর কিন্তু খুব এক্সপেন্সিভ না, এবং জিপিআর কিন্তু অলসো ভেরি ইউজফুল টুল।
জি,
যেমন ওই আশিকের এর থেকে দেখাচ্ছে যে ওটা ডিল্যামিনেশন তুমি বা ময়েশ্চার, জিপিআর in addition to finding pavement thicknesses of different layers, it can detect moisture, right? Moisture distribution, that also, as Ashik indicated, that water and pavement, they're enemies, right?
জি স্যার। আমাদের স্যার এখানে মেইনলি জিপিআরটা মানে পেভমেন্ট পারপাসে আসলে স্যার পরে ব্যবহার শুরু হয়েছে। প্রথমে
হ্যাঁ,
জিপিআরটা
আচ্ছা,
ব্যবহার করছে হলো যে স্যার ওই যে ইউটিলিটি লোকেশন গুলো আইডেন্টিফাই
রাইট, ইউটিলিটি, হ্যাঁ, হ্যাঁ,
জিপিআরটা ব্যবহার করছে। পরে স্যার আমরা মানে পেভমেন্টের জন্য কিছু ব্যবহার করছি আর কি। আর আশিকের কাছে আমার মানে একটা কোশ্চেন যে মানে যেই ফরেনসিক ইনভেস্টিগেশনের যে মেথডোলজিটা তুমি ডেসক্রাইব করলা, এটা কি আমরা এয়ারপোর্ট রানওয়ের জন্য কি ব্যবহার করতে পারবো, নাকি সেটার জন্য মানে ফেডারেল এভিয়েশনের আলাদা কোনো গাইডলাইন আছে?
আমার মনে হয় এটা ইয়ার জন্য ইউজ করা যাবে আর কি, অ্যাজ লং অ্যাজ এটা যদি অ্যাসফল্টের পেমেন্ট হয়, এটা এখানকার জন্য ইউজ করা যাবে। এটা ইজ ভেরি জেনারেল, এটা
আচ্ছা।
খুবই জেনারেল আর কি গাইডলাইন। আপনি ওখানে দেখবেন বেশ কিন্তু বেশ ডিটেলস আর কি, কোন ধরনের মানে কোন ধরনের ডিস্টেন্স দেখা যাচ্ছে, তার জন্য কোন ধরনের টুল ইউজ করাটা ভালো হবে, ভালো ডেটা পাওয়া যাবে, ওই ধরনের আর কি। আমি এই যে এনসিএইচআরপি রিপোর্ট 747 আর কি স্যার, ওটাই
ওটা
আর
একটু
কি বেশ
আমাকে ইমেল করে
পছন্দ।
যদি থাকে, পসিবল যদি হয় পিডিএফটা একটু
জি
ইমেল।
জি আমি
আমরা,
চেষ্টা করবো। জি জি
হ্যাঁ, হ্যাঁ, আমরা আরেকটা জিনিস করবো মিজান, যে আমরা ওই আমাদের প্রেজেন্টেশনের একটা পিডিএফ করে
স্যার
তোমার কাছে পাঠাবো, তুমি তাহলে পাঠালে তখন তুমি যারা পার্টিসিপেন্ট বা আদার্স ওদের সাথে
হ্যাঁ
শেয়ার করতে পারো।
শেয়ার, জি স্যার, শেয়ার করতেছি। ডিয়ার স্টুডেন্ট, তোমাদের মানে তোমাদের কাছ থেকে তো কোশ্চেন পাওয়া যাচ্ছে না, মানে অনেক কিছু কিন্তু মানে জানতে পারবা স্যারদের কাছ থেকে। মনে যা কোশ্চেন আছে ই করতে পারো আর কি, তোমরা কোশ্চেন।
Hello, sir. I'm Shafi. I have completed my graduation last year. So while Musharraf sir was delivering his lecture, uh, currently I am interested in structural health, which I guess also cover the pavement health. And I was
Correct.
searching if sir had any work on structural health, and then I found his paper on assessment of transportation infrastructure health using forensic investigation. And luckily, the next lecture is on this forensic investigation. So thank you very much, sir. And my actual question is right now, sir, do you have any technology that monitors the pavement real time? Like I am installing some device throughout the road and gathering the data in a server real time so that I can be more proactive rather than reactive. Thank you, sir.
রাইট, এখানে শরীফুজ্জামান, এটা তোমার অবশ্যই বিভিন্ন ধরনের টেকনোলজি আমাদের সেন্টারে, এটা তোমার প্রশ্নটা যদি স্পেসিফিক উত্তর দিতে হয় তাহলে আমরা মানে যেমন উই ক্যান টক অ্যাবাউট প্রজেক্টস, ফর এক্সাম্পল তোমার ইউনিভার্সিটি অফ টেক্সাস অ্যাট এল পাসো, ইউটেপ, ওরা আমাদের সেন্টারের পার্ট আর কি। তো ওদের যে ওয়ান অফ দ্য টেকনোলজি তুমি যেটা বলতে চাচ্ছ, সেটা ওদের অ্যাকচুয়ালি রিয়েল টাইম মনিটরিং। কিন্তু এখানে আমার হচ্ছে কি যে এটা ইউ কালেক্ট লট অফ ডেটা আর কি, রাইট? এই যে ইনফ্যাক্ট ওই যে ট্রাফিক স্পিড ডিফ্লেকশন ডিভাইসের আশিক নোজ যে এই যে ডেটার আমাদের একজন পিএইচডি স্টুডেন্ট, he finished his PhD with this particular topic, right? A huge amount of data you accumulate. এখানে যেমন আমি তোমাকে বলতে পারি যে আমাদের একটা প্রজেক্ট ছিল, আমরা 5 বছর এটা মনিটর করেছি। সেখানে এটা তোমার সেন্সর ইয়ে করতে হয়। যেমন আমাদের ছিল যে আমরা মনিটর করেছি ট্রাফিক যে মানে ট্রাফিক কম্পোজিশন এবং অ্যাক্সেল লোড, এটা মনিটর করেছি। তারপরে যে আশিক যে বললো যে তোমার বটম আপ ক্র্যাকিং, যে টেনশন ডেভেলপ করছে লেয়ারে আর কি, এবং ইফ দ্য টেনসাইল স্ট্রেন্থ এক্সিডস দ্য লিমিট, তখন এটা ক্র্যাক হওয়ারই কথা আর কি, রাইট? অ্যান্ড দেন ক্র্যাক উইল প্রপাগেট স্লোলি ফ্রম টপ টু বটম। তো এগুলির জন্য আমাদের স্ট্রেন গেজ ইনস্টল করতে হয়েছে ফিল্ডে, রাইট? অ্যাজ পার স্ট্রেন গেজ। ময়েশ্চারের জন্য আমরা ময়েশ্চার সেন্সর ইনস্টল করেছি। ওয়েদার ইয়ে করার জন্য ওয়েদার স্টেশন ছিল। I can go over that maybe. মিজান, যদি তোমার সময় থাকে, তাহলে I think that is also a very wonderful project that we did for 5 years. এবং এখানে আমার আরেকজন ফর্মার স্টুডেন্ট who is also a professor now, যে রাফিকুল তারাবদার, রাইট? ওরও একটা সিমিলারই আছে। তো শর্ট অ্যান্সার হচ্ছে অবশ্যই করা যাবে, কিন্তু তুমি তাহলে এটা তোমার কস্ট আছে, মানে ইনস্টলেশন কস্ট, সেন্সর ফেল করে, এবং আহ, আহ, এটা ডেটাটা প্রসেস করতে হবে। যেমন ট্রাফিক স্পিড ডিফ্লেকশন ডেটা টেরাবাইটস অফ ডেটা কালেক্ট করে আর কি, রাইট? এভরি ডে, মানে এটা হিউজ অ্যামাউন্ট অফ ডেটা। তো ওই ডেটাটা তো আর ডেটা কালেক্ট করলেই তো হবে না, আমাদের ডেটা প্রসেস করতে হবে, ডেটা কোয়ালিটি জানতে হবে, মিসিং ডেটা, এই অনেক ধরনের জিনিস আছে। কিন্তু শর্ট অ্যান্সার হচ্ছে যে অবশ্যই করা যাবে, কিন্তু এটা আমাদেরকে ওই ধরনের, বিশেষ করে বুয়েটে যারা কাজ করছে, মিজান, আমার মনে তো হয় যে আমাদের তো আসলে ওখানে ফিজিক্যাল প্রেজেন্স দরকার নাই অনেস্টলি। আমরা শেয়ার ড্রাইভ দিয়ে তোমাদের স্টুডেন্টদের সাথে কাজ করতে পারি, এবং ইট উইল বি ট্রিমেন্ডাসলি হেল্পফুল। যে আহ, এই যে আমাদের একজন স্টুডেন্ট যে ইয়ে করেছে যে তোমার হোয়াট ইজ দ্য ডিফারেন্স বিটুইন ইউজিং এআই মডেল টু প্রসেস ডেটা, মেশিন লার্নিং ভার্সেস তোমার যেটা আমরা নর্মালি স্ট্যাটিস্টিক্যাল প্যারামিটার দিয়ে একটা ডেটার কোয়ালিটি জাজ করি। দিস ইজ ভেরি এক্সাইটিং ফিল্ড অনেস্টলি, আমার কাছে এগুলি খুব এক্সাইটিং মনে হয়। এবং ডক্টর সাইদ আশিক আলী is a great example, the type of work that he is currently doing. এখানে আসলে প্রচুর অপরচুনিটি আছে, এবং এই কাজগুলি একসাথে করার জন্য, যেটা আমি ডক্টর বদরুজ্জামানকেও বলার চেষ্টা করছি, যে উই ডু নট নিড টু বি দেয়ার ইন পারসন। আমরা এখন উই আর নট দেয়ার ইন পারসন, রাইট? বাট স্টিল উই আর টকিং। এটা আই এম সরি, তোমার মানে প্রশ্নের একটা লং অ্যান্সার হলো, কিন্তু এটা অবশ্যই করা যাবে।
আর কারো কোশ্চেন?
স্যার একটা জিনিস একটু ডিসকাশন করি স্যার।
হ্যাঁ,
আপনি যে জিপিআর এর কথা বললেন স্যার, একটা জিপিআর স্যার 24 কনস্ট্রাকশন ব্রিগেড ব্যবহার করে, বাট দ্যাট ইজ অনলি ফর দি ইউটিলিটি, লোকেটিং দ্য ইউটিলিটি সার্ভিসেস স্যার।
রাইট।
বাট সৈয়দ আশিক আলী উনি যে জিপিএ টার কথা বললেন, ওটা কিন্তু স্যার একটু ভিন্ন ধরনের। বললেন যে অনেক দ্রুত স্পিডে চললেও ইট ক্যান অ্যাকুমুলেট দি ডাটা ফ্রম দি সারফেস।
রাইট।
জেনারেল জিয়া, ওটা কিন্তু মানে আপনার উনি একদম লেটেস্টটার কথা বলছেন। আর
জি
জিপিএটা বললাম যে আপনার আমরা আসলে ব্যবহার শুরু করছি ইউটিলিটি আইডেন্টিফাই করার জন্য, কিন্তু আপনি যদি পেভমেন্টের উপর দিয়ে ওটা চালান এবং পেভমেন্টের বিভিন্ন লেয়ারের মানে স্ট্রাকচারাল যেই কিছু প্যারামিটার দিতে হয়, সেটা যদি আপনি দিয়ে দেন, তখন কিন্তু ওই লেয়ার গুলোর ফিজিক্যাল কি কন্ডিশন সেটা কিন্তু মানে অ্যাসেস করা যায় আর কি।
এক্স্যাক্টলি।
তাই না
এই যে
ডক্টর?
মিজান, এই যে
স্যার,
টেকনোলজির কথা আশিক বলেছে, এই টেকনোলজিটা হচ্ছে তোমার টিটিআই এর টেকনোলজি, টেক্সাস ট্রান্সপোর্টেশন Institute of Technology, they have been working in this area for 20 plus years, right? তো ওরা হচ্ছে কি ওরা জিপিআর যেটা তুমি অফ দ্য শেলফ জিপিআর আছে এগুলি সব ডেটা প্রসেসিং এর ব্যাপার আসলে সবটাই অনেকটাই আর কি, রাইট? মানে তোমার টুলটা আছে কিন্তু ওই ডেটা টুল তোমাকে ডেটা দিবে, রাইট? মানে টুল উইল গিভ আস ডেটা, বাট হাউ ডু উই প্রসেস দ্য ডেটা and interpretation of data?
হ্যাঁ,
This is
ইন্টারপ্রিটেশনটা
also extremely important in interpretation. তো
জি
এখানে
আমরা
যদি তুমি চাও আমি যে ভদ্রলোক এটা প্রাইমারিলি কাজ করে টিটিআই, কারণ টিটিআই আমাদের সেন্টারের মেম্বার,
স্যার
তো যে ভদ্রলোক এটার ব্যাপারে একদম সব থেকে অভিজ্ঞ, আমি তাকে নিয়ে একটা সেমিনার করাতে পারবো তোমাদের সাথে।
স্যার এটা স্যার মানে তাহলে স্যার মানে ভালো হয় আর কি স্যার, যে ওনাদের কাছ থেকেও টাইম নিয়ে আমাদের স্যার স্টুডেন্টদের একটা এই টাইম তো স্যার সবার জন্যই, মানে আমাদের এখানকার মোটামুটি সবাই ফ্রি থাকে। আমার মনে হয় যে স্যার মাঝে মধ্যেই দুই একটা করে সেমিনার করলে যেটা হবে স্যার স্টুডেন্টদেরও স্যার, কারণ এখন স্যার যেটা হয়েছে যে মানে এই পেভমেন্টের উপরে বা ম্যাটেরিয়ালস এর উপরে মানে কাজ করতে স্যার মানে খুব আগ্রহী কেউ হয় না আর কি। বেশিরভাগই ওই মানে ডাটা অ্যানালাইসিস বা সিমুলেশন এই টাইপের কাজের
Okay.
দিকে বা রিসার্চের দিকে আগ্রহ বেশি আর কি। কিন্তু
এক্স্যাক্টলি মিজান,
স্যার
এটা আমি
স্যার
আমি ওইটাই বলার চেষ্টা করছি তোমাকে, বা আমি ডক্টর বদরুজ্জামানকে বলবো একই কথা আর কি, যে মানে আমাদের একটা স্ট্রেংথটা হচ্ছে কি যে আমরা সবার সাথে কাজ করি। ডক্টর সাইদ আশিক আলী অলসো ওয়ার্কস ইন এ টিম, রাইট? এবং
স্যার
আমরা উই লার্ন ফ্রম ইচ আদার। তো এখানে যে টিটিআই এর যে টিটিআই তো খুবই বড় আর কি, রাইট? ভেরি বিগ, ভেরি বিগ। তো এখন ওর যে আহ, যে ভদ্রলোক যে জিপি একটা ডেভেলপ করেছে আর কি, লেটস হ্যাভ এ সেমিনার উইথ হেম, রাইট? এটা আমি তাহলে তুমি যদি বললে তাহলে আমরা তোমার একটা টাইম ঠিক করো, অবশ্য একটা মিউচুয়ালি কনভেনিয়েন্ট টাইম।
জি স্যার জি স্যার
ওনার টম স্কোলিয়ন হচ্ছে ভদ্রলোকের নাম,
স্যার
রাইট? তো উনি ওনার সাথে তাহলে আমি যোগাযোগ করে বা আশিক যোগাযোগ করে আমরা একটা টাইম ঠিক করতে পারবো। দেন ইউ ক্যান অ্যাকচুয়ালি হি ক্যান টেল ইউ মোর। এবং নট অনলি দ্যাট, আমি তোমাকে এটাও বলতে পারি যে আমাদের এখানে একটা সেমিনার দিয়েছিল সে এই ওকলাহোমা সিটিতে, রাইট? তো উনি যখন ড্রাইভ করে আসছিলেন তার এটা ট্রাকের মধ্যে, ট্রাক মাউন্টেড এটা, রাইট? তো অ্যাজ হি ওয়াজ ড্রাইভিং, তোমার এখানে থেকে মোর দ্যান 100 মাইলস মানে 150 কিলোমিটার ডেটা সে ড্রাইভ করে আসার সময় কালেক্ট করেছে,
সেই দিনটা
ওভারনাইট প্রসেস করেছে, ওভারনাইট ওভারনাইট প্রসেস করে পরের দিন প্রেজেন্ট করেছে আমাদেরকে।
জি স্যার,
কেন
এটা
আমরা
খুবই
কিডিং?
স্যার, ইটস রিয়েলি ইন্টারেস্টিং স্যার।
এই জন্য আর কি, মানে আমি তো খুবই আমি আই এম ভেরি অপরচুনিটি, মানে আই ফিল ভেরি গেট এক্সাইটেড যে যখন আমি অপরচুনিটি দেখি আর কি, যে বাংলাদেশ হ্যাজ সো মাচ পোটেনশিয়াল, সো মাচ, but we are not unfortunately realizing it. But we should, maybe even if it's incremental. তো তুমি যদি মিজান যদি তুমি অ্যারেঞ্জ করো, আই থিঙ্ক আই উইল বি গ্ল্যাড টু টক
স্যার
টু
স্যার
টম
আমি
সুলিভান।
অবশ্যই করব স্যার। আর স্যার আপনাকে তো মানে স্পেশাল মানে থ্যাংক ইউ, সাথে সাথে ডক্টর সৈয়দ আশিক আলীকেও, মানে আমিও মানে আমার স্যার যে ইন্টারেস্ট, আমিও কিন্তু অনেক কিছু আজকে স্যার মানে শিখতে পারলাম আর কি, যে কিভাবে স্যার ইনভেস্টিগেশন গুলো করে। তা আমরা তো মানে একটা মেথড ফলো করি যে আমাদের লিমিটেড রিসোর্সের মধ্যে যেই ডাটা গুলো কালেক্ট করতে পারি সেই ভাবে অ্যানালাইসিস করে আমরা একটা কনক্লুশন ড্র করি। কিন্তু স্যার একদম যদি প্রবলেমটা পিন পয়েন্ট করতে চাই তাহলে কিন্তু স্যার আরো মানে এডিশনাল মানে ডেটাগুলোর আসলে প্রয়োজন হয়, এবং সেটা কি ধরনের ইকুইপমেন্ট ব্যবহার করে করা সম্ভব সেটা আমরা ডক্টর সৈয়দ আশিক আলীর যে প্রেজেন্টেশন সেখান থেকে স্যার আমরা জানতে পারলাম আর কি। স্যার আমি স্যার দুইজনকেই স্যার আমার পক্ষ থেকে এবং আমার স্টুডেন্টদের পক্ষ থেকে স্যার মানে অসংখ্য ধন্যবাদ জানাচ্ছি স্যার। ভবিষ্যতেও স্যার মানে এই কোর্সে আপনাদের মানে পাশে পাবো বলে আমি আশা করি, এবং আমার যারা টিচার স্টুডেন্ট আসবে তারাও স্যার মানে আপনাদের কাছ থেকে নলেজটা স্যার তারা পাবে আর কি স্যার। স্যার আপনি যদি এখন স্যার মানে শেষ কিছু বলে আর কি স্যার আমরা শেষ করি আর কি স্যার।
Ashik, তুমি বলো, then I'll just be saying few words.
No, I would just say thank you very much. Like it's almost like 30 minutes past the class time, and it's still like 80 people on call. So that's amazing, actually. Thank you very much for your presence, and I hope that we are able to contribute a little bit to your knowledge. And if we can be of any help, please reach out to us. We'll try our best to help you. Thank you very much.
মিজান, আমার এটা হলো যে ফার্স্ট অফ অল আই এম রিয়েলি থ্যাঙ্কফুল টু ইউ ফর অ্যারেঞ্জিং দিস, and I'm thankful to Zia and your students, for being here. কারণ আমরা এটা আমি মনে করি যে এটা আমাদের জন্য একটা বিগ অপরচুনিটি আর কি, যে টু বি এবল টু টক টু ইউর স্টুডেন্টস। এবং আমি এটাও করব, মানে আশা করব যে আমাদের যে কনফারেন্সের কথা আমরা মনে করছি, যে আমরা এই ধরনের একটা সেশন করতে পারি যেখানে যারা, এবং আমি জানি না, আই ডোন্ট ওয়ান্ট টু মেক এনি কমিটমেন্ট, কিন্তু যদি ওই সময় যদি টমাস স্কোলিয়ন থাকে অ্যাভেলেবল, ইজ এ ওয়ান্ডারফুল গাই, খুবই ভালো মানুষ আর কি। তা যদি তুমি ওইরকম হয়, ওদেরকে আমরা নিয়ে আসবো, ওরা বাংলাদেশ ভিজিট করুক, ওরা দেখুক যে এখানেও অপরচুনিটি আছে, রাইট? সো এটা আই থিঙ্ক লেটস কিপ ওয়ার্কিং টুগেদার। এবং আই অলসো হ্যাভ বিলিভড, আমি সারা জীবন কোঅপারেশনের মাধ্যমেই আমি করি সবসময়। অ্যান্ড আশিক হচ্ছে আমার লেফট হ্যান্ড, রাইট হ্যান্ড, আই টক টু হিম 10 times or so, I do not know. মানে এটা আসলে হচ্ছে আমাদের আসলে অপরচুনিটি কিন্তু ইনর্মাস। তো যদি আমরা এটা রিয়ালাইজ করতে পারি, এবং ইউ ক্যান অলওয়েজ কাউন্ট আস ইন, প্লিজ কাউন্ট আস ইন, যে আমরা আসলেই হেল্প করতে চাই এবং আমরা হেল্প করা, তবে আমাদের ওইরকম ন্যাচারাল নলেজটা তো টু ওয়ে স্ট্রিট, অ্যাজ ইউ সেড ইন দ্য বিগিনিং। আমরা তোমাদের কাছ থেকে শিখবো যতটুকু পারি, তোমরা আমাদের কাছ থেকে শিখবে যদি আমাদের কিছু অফার করার থাকে। তো থ্যাংক ইউ ভেরি মাচ ফর অ্যাকচুয়ালি গিভিং আস this opportunity. It has been a great, as Ashik indicated, that we still have, I can say, 79 people still, and we are way over time. But thank you so much for the opportunity.
স্যার থ্যাংক ইউ ভেরি মাচ স্যার। ফিউচারে ইনশাল্লাহ আবার দেখা হবে এই আশা করে স্যার আমরা আজকে শেষ করছি।
Inshallah.
স্টুডেন্টরাও তোমাদেরকেও থ্যাংক ইউ।
Assalamu alaikum.
Thank you. Assalamu alaikum.
Thank you, sir. Assalamu alaikum, sir.
Walaikum.
Thank you, sir.